optimal business impact. But first, a very quick introduction by me. My name is Torbjörn Pearson, and I'm the Alliance Manager here at PTC, and leading these weekly webinars where we invite customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. And we are running all these webinars on Friday, same time, with topics around either manufacturing, services, or engineering. And all the recordings of the past web sessions are to be found on the registration site. And the agenda for today is first a very quick overview of PTC by me. Then Jeff will run the show, where he will also touch base on a few challenges, how to address these, of course, and then explain some of the business outcomes. At the end, we're also having a Q&A session, so please keep your questions to the end, or you may actually put them in the chat as well during the session here, and we'll pick them up later. Next slide, please, Jeff. So just a very brief overview of PTC on who we are. And PTC is a global software company with a headquarters in Boston. We provide market-leading solutions on IoT, augmented reality, PLM, CAD, service lifecycle management, and application lifecycle management through the digital thread to help companies to accelerate their digital transformation. Now over to you, Jeff.
Toby, thank you so much. So today, let's go through some of the market realities and market challenges that companies are facing, and see how PTC and our digital transformation helps that process come together. Product innovation is becoming more challenging. Every industry is experiencing faster changing market conditions, factories that struggle to keep up with backlogs, supply chain disruptions. At the same time, lower worker satisfaction is becoming a challenge, and people want to work where and when and how they work. Global competition is more intense than ever. Product innovation becomes more challenging, and to get to market first, you need to look at the issues that you have. Lack of transparency to change and change effectively further exacerbates the problem. For many companies, the larger the portfolio, the greater the quality issue because the systems are not integrated. Engineers, manufacturing, and supply chain teams must do triple work with the same data being entered in PLM, MES, and ERP. That lack of governance means that people do not understand the problems and delays, requiring high degrees of communication with daily meetings across time zones. At the same time, in the market, there is rising expectation from customers and businesses for the products and goods that are being sold. So whether it is being faster to market or delivering innovative products, there's also a greater demand to personalize or have diverse products based upon a platform to deliver that greater product diversity. Finally, in addition, there is always a greater need for improved quality and having more robust ways to deal with cost, supplier disruption, and demand fluctuations. To achieve those, to achieve the goals of those diverse products, of the needs of higher quality, faster time, better collaboration, companies that are successful are tying together their data and processes across their strategic manufacturing support systems, including PLM, ERP, and MES. So how are companies leveraging these tools to handle these different challenges, and how can they help? So looking at the range of challenges that customers have, how do you handle configurable products across your multiple systems, including PLM, ERP, and MES, so that you have consistency? How do you ensure that there is common understanding of alternatives for product designs? Making sure you've got the latest versions of software identified for production line and determining impact on testing. Do you also have the capabilities to manage the cybersecurity and IP protection of your product data? In order to meet these needs and collaborate across this thread of PLM, ERP, and MES, we look at PLM helping to fix the broken tool chain as well as to help bring the data together. Incorporating PLM from the very beginning of product innovation process and throughout the engineering and manufacturing preparation, rebalance the boundaries between ERP, PLM, and MES, connecting everything that matters in product development and manufacturing via the digital thread. To be future ready, manufacturers must evolve from point-to-point integrations. This allows the engineering team's data to be available to the manufacturing and supply chain teams, making the collaboration earlier in the process, as well as then enabling it across the process flows. So PLM allows you to identify and address the issues of making sure that your data processes are tied together, that you have complete and accurate data, have the ability to manage these complex configurations, and have the granularity of the data that to drive to ERP when it's needed and to MES when it is needed. So the first step in managing the right data in the right tool is with a common product master data approach, allowing seamless product integration to determine your product master data, clean it up, and then making sure you have the ability to share this data. ERP, for example, does not own the upstream product and manufacturing information, so has limited capability for creating, defining, optimized manufacturing process plans for a product that is complex and changing. Further, an efficient engineering change process needs to trace back and reflect the latest changes in product design. A direct bidirectional change management process between PLM and MES is efficient and reliable. Modernization starts with contextual and traceable product information with views across the product lifecycle. So taking a deeper look at this, and this is a bit of a detailed view of the different processes that are unlocked by these different tools and how they enable and support each other. So PLM, of course, is the core of your product data management, including your mechanical and electrical, your bill of material and product structure, the modular platform capabilities, as well as ties in your requirements from your ALM tools, and has the deep and rich lifecycle product management to ensure the governance of this data over time. It further allows the BOM transformation to manufacturing and service BOMs, and then process plan definition, so that these teams can start working earlier in the life cycle and making sure that manufacturing has greater collaboration capabilities with the engineering teams. ERP then ties in the physical and logistics information like plant and storage location, sourcing, financial and accounting, production planning, and change process that is more production shop floor related. It also is the center for your procurement and material management. Your MES tools can then focus on what they do best: production scheduling, genealogy of the production. So what did you actually make? Delivering the work instructions to that have been created from your rich data in PLM, as well as data collection of what is engaging on the shop floor. Customers who are doing this well are increasing the value of the PLM implementation with this integrated concept of bringing this data together. Let's take a start by looking at how Windchill enables the digital thread for the backbone of this process. At its core, Windchill enables the ability to drive a robust product definition, tying together your CAD and your EBOM, both bottom up and top down, as well as linking in requirements from external systems. This can be used for single bill of materials, as well as the ability to plan a configurable product platform to deliver very diverse configurable offerings of product families, managing the logic and generating variants for multi-year product structures. This robust product configuration can then be used in the BOM transformation and process planning capabilities. So you have consistency and associativity of the data between manufacturing and engineering, the ability to then use that to plan for different manufacturing needs for different sites across the globe, and then leverage those for a process plan that can also vary by site or different product lines. By having the engineering and process planning teams tied earlier and often into the engineering cycle, this allows the teams to collaborate and have the right discussions early in the process to lower costs and get to market more quickly. The same processes that allow the rich manufacturing BOM planning also allow the ability to do service planning, service and parts list information, and create technical publication and illustration data using this rich product information throughout the cycle. This foundation also delivers very robust and scalable product visualization and augmented reality that can be used to drive product and variant configuration visualization around the enterprise. All of this is wrapped in a common change management governance, so there is a common understanding and capability across the digital thread. Taking a deeper look at how this then allows the digital continuity and collaboration across the life cycle, if we look at this example, we can see we have the engineering BOM and the manufacturing BOM associated. The manufacturing BOM is then leveraged to create a set of process plans that can be leveraged for single or configurable products. The abilities are very robust, allowing you to do different breakdowns of these processes for different manufacturing sites across the globe. The results of this also allow you to give work instructions, technical descriptions, parts lists, resource lists, and have a rich set of information that is collaborated on more early and often. The results of this can then be delivered to downstream systems such as ERP, supply chain management, as well as MES systems to do process planning and execution on delivery to the shop floor. The results of this from an MES system can also be fed back to the digital thread, allowing the loop to be closed to get better information and results from the actual manufacture of it and its impact. This can then result in information leading to a change, and because all of this data is associative and connected, this change and the understanding of the equivalence of this change is then easy to tie together using BOM reconciliation tools to understand and quickly have the engineering and manufacturing teams understand and deliver this updated product configuration across the life cycle. So let's look at some of the process flows that these capabilities then enable across the life cycle. So we look at the ability to have bi-directional process flows, allowing manufacturing planners, detail planners, plant and tool designers to have the access to the most updated information from engineering. Design engineers also then are enabled to have real-time feedback from manufacturing. The ideal future state involves integrating the flows and not the data by providing the access to PLM data into and from existing MES and ERP systems with a single source of truth. Manufacturers avoid having multiple systems mastering the same data at any given time, allowing users to focus on the work that provides value in those systems. With connected systems, it's important to understand how much definition you plan to pass, where one stops and the next starts. This allows the users to turn data into insights, helping drive aligned decision-making and automated process orchestration across engineering and manufacturing. The goal is to close the loop with built-in automation and reporting that covers all phases of manufacturing, especially in MES. So one of the first steps that we see commonly is the link between PLM and MES, starting with the ability to define and deliver and share part and BOM information between PLM and MES. This allows each system to focus and do what it does best in the product lifecycle, allowing the engineering and manufacturing teams to focus on the product and process definition, while our ERP focuses on the transactional power and business process flows of what it takes to order and get that product definition into the enterprise. This allows the data to flow from PLM as well as important information like cost or ERP-specific attributes needed by manufacturing and design engineers back to PLM. There is also a change management governance process that allows changes in PLM to be shared to ERP so that ERP has a rich understanding of the work that engineering and manufacturing planning are doing. At the same time, the right information, as we looked at just a few slides back, can be provided to MES, again, allowing the manufacturing execution teams to focus on the specific execution planning supported by rich data from PLM, including the latest updated changes, the manufacturing control plans and process plans, rich data from CAD like CNC controls, as well as the process configurations and detail needs for quality inspection. MES can then provide PLM and Windchill with data such as non-conformance, so issues and incidents that come up on the shop floor, as well as calling out variances like deviations and waivers. This also allows the ability from data from MES to come back to the engineering system. And so one of the things we don't call out in detail, but we also allow in this set of slides, is we have the ability to define and manage model-based enterprise and control characteristics from CAD through PLM and process planning and expose that down to MES. As the execution starts to track and manage these control characteristics, that can trigger inspections and control activities, and of course can be provided as feedback to the engineering cycle. Communications, to be valuable, also need to flow between ERP and MES. So ERP will provide product information for cost estimates and overall goods. MES can help drive how many components will be consumed and help control inventory. So you have and then resulting in a bidirectional flow of order, demand, commits, and built and finished good inventory updates, allowing that process loop to be closed. The next step is helping to turn this data into actionable insights, whether it's leveraging our lighter weight Navigate apps to expose the PLM data down to the shop floor, or leveraging those IoT capabilities to deliver that data back to engineering. So the specific KPIs and measurement information of critical quality data can flow back to ERP. This allows operations tied back to engineering, delivering a seamless experience, and allowing and ensuring that the entire enterprise has access to the right PLM data at the right time. One of PTC's next steps in this will be to deliver a set of manufacturing apps geared towards the shop floor user. So coming in our fiscal year 25 with our first release planned for this coming December, we will be offering a set of Navigate for shop floor capabilities that extend PLM to the factory shop floor, enable work instruction viewing for operators, providing critical visibility into information such as steps, description, and documents. Part data including 2D, could be 2D drawings or images, 3D and animation, tool information, and control characteristics. The goal is to replace that binder of papers that the teams need to work to keep up to date with accurate digital work instructions required to build a specific product, ensuring that the teams always have the right information at the right time, reducing errors in delivering physical binders, modernizing training and operations in the workforce. What that will be looking like over time is it will be a journey. So in December 2024, our first release will focus on replacing the binder with 3D digital work instructions, including specific plant and workstation level work instructions. We will then allow the worker to provide feedback, such as creating non-conformance or problem reports. So issue and incident information to feed that back to the engineering and manufacturing teams. One of our next goals is to make this capable to embed in into an MES system, so that users don't have to change out of environments that they might normally work in while they're on the shop floor. And then also delivering worker-specific instructions, enhanced authoring capabilities, and mobile device support, allowing for a rich set of work instruction and manufacturing feedback that is geared towards the specific needs of users in the manufacturing shop floor environment. So keep an eye for that first release coming this December, and the continued enhancement to this over time to bring greater value to that shop floor user. Once the foundation is established with the digital thread of your product data across a connected PLM, ERP, and MES landscape, you have paved the way for moving fast into implementing Industry 4.0 at scale, such as augmented work instructions, virtual build training and ramp up, AI-enhanced inspection forms. Integrating your digital thread to IoT platform brings the power of enabling the next generation connected worker who is equipped both with real-time information of the equipment, as well as the ability to carry out the work effectively and efficiently. The connected worker doesn't need to knock on office doors, go up and find the engineer or designer, or dust off training manuals, unlocking this across the enterprise. If you want to find more detailed information on PTC's view on connected systems in discrete manufacturing, we have a white paper. So you can use the QR code that I'm displaying here to access this white paper and dig into deeper and additional information. So at this time, I'm going to jump over to our Q&A session and also provide you with my email if you have questions that you might want to follow up with offline. So on that note, Toby, why don't I turn it over to our Q&A portion?
Thank you, Jeff, for sharing your insights here in this very core area to PTC, of course. And as I said, now over to the Q&A session here. So, you may raise your hand and we will open up, for you to ask your questions. Or we could also pick up some of the questions in the chat, and I have some other questions also coming in here from other sources. And I had actually one question that actually came up in a recent CXO event that we were running here with customers in Stockholm this week, and that was regarding a customer I had to talk to, and he was asking, we are upgrading our ERP system. It was an SAP HANA. What should we look at with the Windchill if we are looking to improve how the teams create and share the data?
That's a great question, and one that we get quite frequently. As you are looking to update your ERP implementation, it's a great time to look at your processes and understand where you are creating value or where you are adding work. One of the most common points that we see, and one of the ones that unlocks a huge amount of value, is allowing in ERP systems such as SAP HANA to consume the product definition that is created by engineering and manufacturing, so an EBOM or an MBOM, and start that collaboration cycle earlier, reducing the need to manually key in that information, which can introduce errors and adds more time to the product development cycle.
Right, thanks. And another question, actually a little bit related to that, was also on how and what can Windchill feed to our MES system?
So it's a good question, and it's an area that we're seeing a lot more interest in the past few years, as customers, again, are looking to avoid duplication of work. So Windchill is able to provide, of course, the results of the product data from the change process, and most importantly, deliver to the MES the process plan that can be created from an MBOM, allowing that system to focus on the execution and not try to be a system built for authoring or creating those processes, where in MES really focuses best on the execution of those processes.
All right, thank you. Yes, I had one question in the chat here from Shiram, and you asked about, does the navigate for manufacturing mean an alternative to the connected work cell solution?
So think of this as the evolution of the connected work cell solution. So this is kind of an evolution of the concept for connected work cell, and will be the path that you will see for the shop floor work instruction, consumption, and delivery moving forward. Great question. Thank you.
And then I had another question also in the chat here from Ravi. Can you please explain the use case of first article inspection from PLM to MES?
So first article inspection from PLM is allowing, again, the engineering and manufacturing or quality teams to define the definition of first article inspection, where the definition can be delivered to MES, and MES is, of course, responsible for the execution of that first article inspection. But because PLM has the the deeper understanding of the product definition and things like control characteristics, it becomes a good spot to start to manage the definition of the actual document that's used for FAI.
Thank you, Jeff. And I had another question here as well. How often or ready are manufacturing companies in general by expanding the digital thread into the service department? And could you give any kind of, examples of any kind of companies leading in doing this?
So we find that varies greatly, but companies that are leading this tend to be companies that have complex products with a deeper aftermarket sales and service need. So an example of this that has presented at the conferences as an example is solar turbines, where they leverage the digital thread for EBOM and MBOM information, but also drive that into their technical publications and use it to drive their service BOM planning.
Right, thanks. And I think I'm just looking to see if you have another question here. Let me see here. What's the typical time to value of when implementing a digital thread strategy?
So that really, I don't know that there's a single answer for that. It tends to vary depending upon the types of challenges, how mature a company is in their adoption and their processes. There are some good white papers on this that can be found on the ptc.com website of companies who have unlocked their process, the process value. And I'm drawing a blank on one of the companies, but there's a great article on how they modernized their change management process into PLM and then connected that with their SAP system and unlocked a huge amount of value and lower time in call it a 2-year time frame from kind of inception of process to getting it down to the end to end in the enterprise. And so there's a number of good white papers that can be found on ptc.com for examples like that.
Fantastic, thank you, Jeff.
The company is Vaillant. So there's a great white paper from Vaillant on their journey there.
Perfect, thanks a lot. And time is unfortunately running out. So many thanks everyone for joining this session here, and of course a very special thanks to you, Jeff, for sharing a lot of great information here. And so with that, I hope to see you back already actually next week on 13th of September at the same time for a session about integration of PLM and ALM with Matthew from Transition Technologies. So stay tuned for that and have a fantastic weekend, everyone.
Thank you very much.
Bye-bye.